Good morning, good afternoon, good evening, everyone. Thank you for joining us today. Welcome to this webinar, part of the ongoing series hosted by ISO Technical Committee 347, Data-Driven Agri-Food Systems, as part of our commitment to transparency, engagement, and inclusive participation in the standards development process. ISO TC 347 is a new and ambitious committee working to develop international standards that enable trustworthy, inclusive, and effective use of data across agri-food systems. My name is Andres Ferreira. I'm the chair of TC 347, and I'll be your moderator for today's session. Our webinar series is designed to explore key technical areas where standardization can support innovation, sustainability, and interoperability in agri-food systems. Today's topic is supply chain visibility with EPCIS and the GS1 Web Vocabulary, an overview of GS1's data sharing open standards as a foundation for interoperable data-driven agri-food systems from farm to fork and beyond. EPCIS, also published as ISO IEC 19987, is GS1's open standard for sharing information about status, location, and transformation of products and assets with stakeholders along the entire value chain. EPCIS's linked data support is underpinned by integration with the GS1 Web Vocabulary, an extension to schema.org. So today we'll learn about GS1's EPCIS standard as an event-based enabler of supply chain visibility, tracking of aggregation changes, and transformation of products and assets. We'll also learn about the core business vocabulary, a companion standard for EPCIS, and show how you can actively participate in shaping upcoming international standards. So we're very fortunate to be joined today by Craig Allen Repek and Mark Harrison. They'll lead us through today's discussion. Between the two of them, Mark and Craig bring over 40 years of development work on GS1-driven supply chain standards, including EPCIS. Craig, Mark, you have the floor.
Appreciate it. Thanks very much, Andres. Welcome, everyone. EPCIS is not only a GS1 standard as part of our data sharing portfolio, it's also an ISO IEC standard. It's been published by ISO IEC as 19987 since 2015 and continues to be updated corresponding with GS1's updates. EPCIS has been set up to enable the data carrier neutral sharing of supply chain visibility data. That means it works great with RFID, but it works very well with barcodes as well, 1- and 2-dimensional barcodes. The standard is a very detailed specification accompanied by artifacts, which on the one hand defines a framework data model and also specifies a set of interfaces for the capture and query of event visibility data. And how this works is that the completion of each business process step along the supply chain, where this is captured by the stakeholders, each of these is captured as an EPCIS visibility event. Each of these events provides details, ideally, about the what, when, where, why, and how of what's going on. So the what objects are the subject or the focus of the event. That it can typically be a G10 and SG10 at serialized global trade item level or an SSCC to identify logistic units. When has this happened? So a date timestamp, the date, time zone in effect when the event occurred, where this occurred, and where are the objects thereafter. This could be a global location number, a GLN. It also could be geo-coordinates in case there's no unique identifier available for that. You can use geo-coordinates to capture the where. So this is where it happened and also where you can expect to find the objects afterwards until subsequently updated by later events. Why is the event taking place? Are we capturing this because something is being commissioned, packed, unpacked, shipped out, received, disposed of, etc.? And what is the status or disposition? Is something in transit? Is it available? Is it being serviced, etc.? Has it been recalled? And finally, more recently, a couple of years ago, when we modernized EPCIS, EPCIS 2.0, we added the how dimension. In other words, how fast, how warm, how acidic, how radioactive are the objects being captured in the event. And we did this to underpin automatic inclusion of sensor-based monitoring data. And as I mentioned, 4 years ago, we updated EPCIS, initially published in 2007, and in 2022, we published EPCIS 2.0, which introduces a set of new features to increase the standard's versatility into the coming decades and also to lower adoption hurdles. We'll get into a little bit of that. In talking about the what and the where dimensions, I mentioned identifiers that are standardized by GS1, like the SG to the SSCC, which is ideally what we want to see to increase interoperability. But it's important to remember that EPCIS was set up from the beginning, not only as data carrier neutral, it's also identification system neutral. And that means in all the fields where you have something like an EPC list, child or parent, all that's required is a valid URI. So ideally, you're all speaking the same language with your stakeholders, trading partners, but there's no requirement that that be GS1 identification. And this makes sure that EPCIS also is ISO IEC 19987 is really a completely open standard in conjunction with its companion standards, the GS1 Core Business Vocabulary, the CBV, which is also published as ISO IEC 19988. There's no lock into any identification system. Even though we generally speak very frequently about EPCIS and sometimes neglect to mention the CBV, the Core Business Vocabulary, this is the companion standard which goes a step further in ensuring interoperability, because the CBV ensures a common understanding of data semantics. It's essentially a set of code lists, and it specifies the unique identifiers and unique identifier formats for the what and the where of EPCIS events. With CBV 2.0 adding support for GS1 digital link URIs. So up until that point, you're restricted to URNs. And it sets up code lists which now have added web URI equivalents and browsable online definitions, makes it a lot more flexible than earlier generations of the standard, which were restricted to URNs. And the data model for EPCIS and the CBV are both published as machine readable and browsable ontologies. You see the links here, and I think we've included these references, these resources later on available. The GS1 Web Vocabulary, which is also used heavily in conjunction with EPCIS, and Mark will say a bit more about that later on. This is also available as a browsable ontology in addition to the machine readable files. Together, EPCIS with the CBV and increasingly in conjunction with the GS1 Web Vocabulary and the power of linked data enable supply chain visibility, which as we see it is broken down into tracking what are the current whereabouts of my assets or shipped products, tracing, looking back upstream, what path have these assets, product shipments followed on their way, custody, sometimes referred to as chain of ownership or pedigree, provenance, which parties have had contact with these assets along the way, inventory, and that means knowing not only how much of a given asset or product you have in certain locations, it means also when are they expiring and which ones are expiring soonest, so you can improve your first in, first out, first expired, first out operations. MRO, used, for example, increasingly in the rail sector, keeping track of technical components as they're installed and taken out from maintenance and repaired or replaced, as well as recall, finding impacted instances downstream and following progress of these recalled items back to the market authorization holder or to their disposal. So that's at high level how we see supply chain visibility, and EPCIS was set up to enable that. We won't go too deep into the details on EPCIS, but we did want to highlight a few of the main, most important features that we see as versatile across all sectors. One of these is aggregation, and aggregation has been in the standard since it was initially published back in 2007. Aggregation in EPCIS context deals with the creation or dissolution of parent-child logistic hierarchies, where the parent is one mandatorily serialized containing object, and the children are one or more contained objects which are optionally serialized, but they don't need to be serialized. And you see aggregation used in the supply chain wherever we have packing and unpacking steps, and this can be done in an iterative way as necessary, as depicted here. And this helps keep track of logistic and packing hierarchies. It also enables the practice of inference, meaning you don't have to rip apart all the layers of packing to determine what's at the bottom layer. So in the absence of RFID tagging, if everything is barcoded, normally you would have to be able to scan all the barcodes. But if you're receiving aggregation information from upstream, from trusted partners, you can use this in conjunction with inference to know what you have beneath those layers within the hierarchies. EPCIS also captures the transformation of products and assets, and this was a feature that was added back several years ago before we did EPCIS 2.0. Transformation in EPCIS context involves the input of one or more objects, which are then irreversibly changed. They have new characteristics and a new identity, and they come out the other side as one or more output objects. And this can be leveraged very effectively to reflect transformation in the upstream processing of raw materials, whether it's the healthcare sector, petrochemicals, agri-food, meat, etc., including but not limited to consumer electronics and textile apparel, to reflect upstream processing and what happens to products along their life cycle in order to capture circularity processes. And we think that this is going to play a big role in the years ahead with an increasing number of regulations around circularity and sustainability. EPCIS 2.0 features a number of new aspects, one of which is the how dimension that I touched on the initial slide. And the how dimension was brought in along the what, when, where, and why to enable the capture of sensor data for monitoring the condition of products and assets in manufacturing processes, in industrial IoT, to capture things not only like speed, temperature, acidity, radioactivity, but also to be able to capture things like concentrations of chemicals and microorganisms for safety and quality and assurance. And that's probably an area which is extremely important to the sector that you guys work in. Also can be used effectively in cold chains to make sure that temperature thresholds are not exceeded. One of the tools that we've added along the way is the EPCIS Sandbox. So this is a free online tool which you can use to set up events, generate them, capture them, view them either in XML or JSON LD form. You can convert them between EPCIS 1.x, EPCIS 2.x versions, also between XML and JSON LD, as well as converting the identifier syntax between EPC URNs and GS1 digital link URIs, or the URNs and web URIs. Also provides support for event hash generation for event IDs, and allows you to set up queries so that you can effectively pull the data you need out of events which have already been captured. And we're expanding this to include subscription support. So I would encourage you to check that out because it allows you to get a hands-on feel for what EPCIS event data looks like. At high level, at a glance, the enhancements that we've added to EPCIS CBV, so we just touched on sensor data. It also includes now support for JSON LD syntax. So for the first 15 years, EPCIS was based on XML only. And then finally, after a number of years of requests, particularly from the developer community who wanted a more modern agile syntax, we incorporated support for JSON LD, and we're really excited about that not only because of the opportunities it brings with incorporating linked data. We've also brought in, alongside SOAP and WSDL, which were the interface bases for the first 15 years of EPCIS. We've also added support for REST API for capturing and querying event data, also catering to more modern and mobile applications, which is exciting. We've allowed for the use of GS1 digital link URI syntax now, instead of the EPC URNs. And one main advantage to this is that these are resolvable web URIs, so that ideally takes you directly to online information about the identifier you're looking at, about the serialized GTIN, about the GLN, identifying the location, etc. And Web UI vocabulary, which is linked to online definitions for all the fields. So when you see something in the event, you don't have to go thumbing through the PDF. It's much easier to find this for developers and for users. And we also have increased integration of the GS1 Web Vocabulary, which Mark is going to say a bit more about as an extension of schema.org. Why align with EPCIS? EPCIS is an open standard which provides a standardized way of interoperably exchanging supply chain visibility event data, such that business context can be communicated between trading partners and other stakeholders. It's an open standard, already well supported by an increasing number of implementations and software products. And both EPCIS and the CBV are designed to be applicable across multiple industry sectors, whether it's agri-food, healthcare, rail, technical industries, meat traceability, etc. And although EPCIS and CBV as GS1 standards are already open standards, they're also published as ISO IEC 19987 and 19988, which is important for anybody running projects where the requirement is to have ISO standards. It doesn't make them any more open, but it's nice to have addition to that. So with that, I'm going to hand over to Mark, who's going to give us a look at what's going on with the web vocabulary and how we've increasingly integrated that.
Okay, thank you, Craig. So the GS1 Web Vocabulary is an external extension to schema.org. Schema.org itself was co-founded by Google, Microsoft Bing, Yahoo, and Yandex. It's a very broad linked data vocabulary for describing all kinds of things, including people, events, places, organizations, products. But it doesn't go into a lot of depth in some of these areas. So what the GS1 Web Vocabulary does is to allow you to describe products, organizations, and locations in much more detail. And to do this, we've imported subsets of the GDSN data model and also global product classification, attributes and values, the code lists there. And all of this is formulated built on linked data standards such as RDF, RDFS, OWL, and SCOS, coming from the World Wide Web Consortium, W3C. And we see this as a very low-cost way of publishing and also exchanging structured linked data via the web. So you can publish this as a block of JSON-LD directly on your website or embedded within an HTML web page. And you can also query that just by making a web request, or you can send the data by whatever transport means you like. Okay, next slide, please. So we talked about describing products, places, organizations, locations. This slide focuses on the class which is called GS1 Place. So this extends the schema.org place class. And you can see here that we can express quite a number of different attributes of places. So things like the global location number, a 13-digit string that GS1 uses to identify both places and organizations, but it also has mappings to geo-coordinates, latitude, longitude, geo-shapes, so polygons that could be used to map out a boundary of an agricultural field, for example. Postal addresses, also the hierarchies between locations, so you might have a warehouse with various storage bays and shelves. So you can have parent locations, sublocations, we can express that. And we've got code lists with many more code values than you see there to express the role of a particular location or also the role of a particular organization. Then looking at the relationships, we've got various properties defined for expressing management relationship, leasing relationships, occupation, whether a particular place is the primary location of an organization, etc. There's many more than you see on this slide, but we've got quite a rich vocabulary for describing places and organizations and the relationships between them in quite a lot of detail. Next slide, please. Here, we're looking at products and logistics units. So whereas schema.org has fairly basic properties like weight, we go into a bit more detail. So we distinguish between, for example, net weight, the drained weight, the gross weight. And whereas it has width, depth, and height, well, we think about, is that the packaged width, depth, and height, or is it the out of package that once you've taken the packaging away, what is width, depth, and height? We also have properties for diameter as well. Then thinking also about sustainability and packaging, we've got quite a lot of properties for describing the packaging shape, the material, recycling schemes and recycling processes, returnable deposits, and so on. So we can, and this is only just a snapshot of part of what we can express. We'll see a little bit more on the next slide, which looks at, for example, wearable products. And you can see, so within the GS1 product class, we have subclasses. So one for food, beverage, tobacco products, which are particularly relevant for this audience. Also another one for wearable products, and within that further subclasses. So we've got one for, within food, beverage, tobacco, we've got a subclass for fruits and vegetables, seafood, etc. We'll see that on the next slide. Within wearables, we've got one for footwear and one for clothing. And you see that we can express a number of properties within each of these to be able to describe product in quite a lot of detail, maybe the material composition or the ingredients of a food product, etc. Okay, here's one which is probably more relevant to this audience. This is the looking at food, beverage, tobacco products. So, for example, things like the sharpness or firmness of cheese and the maturation period, or if we're looking at fish, what was the catch zone? Was it farmed? Was it freshwater farmed, seawater farmed? Beverages, percentage alcohol content. Is it carbonated? What is the vintage, etc. And then also quite a lot of detail on all the nutritional information that you'd find on the label pack. So details about calories, fat content, protein content, vitamin content, and also information about dietary aspects like allergens, suitability for various types of diets, and other factors that are relevant to consumers, like whether it contains genetically modified organisms and so on. So there's quite a lot. There's even more than you see here. But it does let you describe food products in quite a lot of detail. Mostly it's focusing on the products that are sold to the consumer, but as part of the work that we're doing in the EU deforestation regulation, it's likely that we'll also be looking at adding some properties that are more appropriate for describing the food commodities, the raw ingredients that go into that are eventually processed into food products. So there will be some expansion there as well. Next slide, please. Here's an example. This shows how GS1 digital link URIs and QR codes and the GS1 web vocabulary can fit together. And if you scan that QR code with your phone, you will see a product information page for this fictitious product about a nutty muesli made by squirrels. But what this link shows you is that if you just want the machine readable data, the structured data, you can append link type equals GS1 master data and also specify you want the data in JSON-LD format. If you do that, then you'll get what you see on the right-hand side there, which is just a snippet of the JSON-LD structured linked data about that product. And you can start to see there's a GS1 digital link URI identifier in bold type. So after the /01, you've got the GTIN, you've got the product name, description. You can have ingredients, allergens, all kinds of information. So this is really about how we're trying to make products much more interactive. There is an initiative within the GS1 community to move towards 2D barcodes that are web enabled, have these GS1 digital link URIs that work like web addresses, but you can also use them within the data itself, whether that's within the EPCIS event data or in master data expressed using the GS1 Web Vocabulary. And those GS1 digital link URIs allow you to identify and describe things at various levels of granularity. So at the GTIN, that's the courses level, you identify the product class. So you can think of that as the stock keeping unit, but as a globally unique identifier that links to various data about that product at the class level. At a finer level still, you can combine that with a batch or lot identifier, which might correspond to a particular production run. And that's useful for things like expiration date, freshness, and also recalls at a finer granularity. So you can recall a specific batch or lot if there's a problem. And then at the finest granularity, you could combine a GTIN with a serial number, and that should identify exactly, uniquely, one instance of that product globally anywhere in the world for all time. So that is the finest level of identification, which supports really fine-grained traceability. So you can actually, each individual product instance has its own unique path through a supply chain network, which emerges over time. It's not predetermined by the brand owner or manufacturer. But in combination with EPCIS event data, you can record very fine event details collected by each of the organizations who processes or handles those objects. They can all be stored, even taking into account all the changes of aggregation that Craig mentioned earlier. So you can do that end-to-end traceability using really fine-grained GTIN plus serial number to identify the product. And those can be used also within the linked data, whether it's EPCIS event data or data using the web vocabulary. So this GS1 digital link URI is not just a way to find the data, but you can use it within the data itself to express the facts, express which objects were seen at this location at this time, or here are some facts defined for the GTIN, so the product name, description, and then others that might be defined at a finer granularity, like the expiration date or the best before date for a particular batch or lot of product, or even down to serial level. Okay, thank you. You can browse the GS1 Web Vocabulary. We've provided a tool, a web interface, which is very richly hyperlinked, so you can see all of our classes, properties, code lists, code values. So if you go to ref.gs1.org/voc, voc for vocabulary, you can explore all of that. You can also search by keywords. So if you're not sure where to find things, you can just explore that way. Okay. How EPCIS and the GS1 Web Vocabulary fit together? Well, both of these are effectively semantic knowledge graphs. So each event has various dimensions. As Craig said, there's the what, where, when, why, which we sort of translate into, things like event time, the read point and business location, the EPC list, the list of the actual objects, etc. So you've got a graph for event data, but then sometimes you might have a need to express a small limited number of master data attributes that are relevant for whoever's receiving the event, so they have a bit more context information. It might be expressing what the role of a particular location was, so where the event happened. It gives them a bit more context than rather than just seeing a global location number as a URI. It says, oh, and by the way, this thing is the refrigerated storage area, or this is the warehouse, etc. So you can express roles and things like that. So to connect these two different types of knowledge graph seamlessly, we've got a property within the web vocabulary called master data available for. And we can use these GS1 digital link URIs effectively as the hubs for these knowledge graphs, and you can connect them. And what this property says is this EPCIS event has master data available for these GS1 digital link URIs. They might be product instances or product batches. They might be locations or organizations. And then seamlessly, the knowledge graph for the master data can use those GS1 digital link URIs as the subject. So that's a way of making sure those graphs connect together rather than the master data being detached or isolated. So that just, it means that when you put master data using web vocabulary into EPCIS event data and extract the link data triples, the facts, then it all ties together. Okay. I think over to Craig for this one.
Thanks, Mark. This is just an overview of some of the online resources that we have available for you to access, and encourage you to have a look at it. These are, I think, most of these are links that we had touched on in the course of our presentation. So we have say, business or marketing oriented overview of EPCIS, the landing page at www.gs1.org. That will give you a high level explanation of what EPCIS is and does. But if you want to get down into the weeds, the standard and the artifacts, both the current versions and the older archived versions, are available within this space called ref.gs1.org, which is intended to be a permanent repository, even if we start reassembling how let's say the business marketing www site is done. These links will be permanent. So if you go there, that'll take you to the top level, and you should be able to get into the current standard and its artifacts, as well as older archive versions. The same applies for the CBV, also at ref.gs1.org. It also applies to the EPCIS data model ontology browser, which, as Mark said, this stuff is very richly linked. So you can look at that for the EPCIS data model, the CBV data model ontology, as well as the GS1 Web Vocabulary. In between here, we have the link to the EPCIS sandbox, which is, you don't need logins for any of this stuff. All of this is freely accessible. That includes the EPCIS sandbox. So there's no need to register, and there's no charge for using any of that. So these are resources for the community, so that you have direct access to the normative standards, the normative artifacts, and some examples and accompanying documentation, and so that you can benefit from the tools to help you get a feel for EPCIS and to try to support your implementation, keeping in mind that the sandbox is meant for testing and piloting. It's not intended to be the basis for a live commercial implementation, although it's certainly a very effective tool for validating your data. So with that, Andres, I think we're at the point where we segue into some of the questions, provided there are some.
And can we go to the next slide? So before we tackle the questions, let me contextualize all this a little bit in with respect to TC347, right? So we've seen some really exciting tools here and some very stimulating ideas. And GS1 is a liaison organization into TC347, and we are actively looking for opportunities to both use their standards in our work and have some of our work and needs that our members identify inform some of their work, right? So it's turning into, I think, a kind of high bandwidth exchange with GS1, as we want to have with all our liaison organizations. So if you're interested in joining the work that TC347 is doing, here's a sort of little intro to that. Most of the work happens online. We spend most of that time together in small working groups, ad hoc groups, and advisory groups that meet relatively often, but set their own schedule. But twice a year, we have what are called plenaries, where all the members of TC 347 meet. One of those is always virtual, which happens in October. It's 2 half days in October. And then the other one, when we can, we make it be in person, preferably in March. That's a 4-day event. This year we had it in Cologne, hosted by none other than GS1. And last year we had it in Berlin, and we'll keep rotating countries and so forth. Now, there's 2 ways of contributing to TC 347's work. One is through your national standards body. So you become a member of your national mirror committee, and that way you can participate directly in the work, and you can help your national mirror committee vote and come up with its position when there are ballots and other decisions to be made. Or you can participate through a liaison organization. We have 11 liaison organizations right now that range from like Ag Gateway and AEF to things like the International Society of Precision Agriculture or the Pan-African Society of Agricultural Engineers. Liaison representatives can participate directly in the work of our subgroups. The only thing they can't do is vote, which isn't very important when coming up with those drafts. So if you have questions, if you're excited about this, please contact us. You can see some basic information there to be able to do that. We're, I think, quite easy to find. So with that, now I think we can transition to questions, and I would invite our attendees to put their questions in the chat, and let me start with a few that I have. For example, is whether the objects that EPCIS can track, are they strictly physical objects, or can EPCIS also represent the chains of custody of digital objects too?
There's nothing to prevent tracking of digital objects using EPCIS. So a GTIN can identify a product or a service, and that product can be physical or virtual. The EPCIS event data model and the standard do not actually check the validation for the type of identified thing. There are constraints, but they will typically tolerate a URI. So any web URI could be used with EPCIS. It might not necessarily be CBV conformant. There's further guidance within the core business vocabulary if you want to be fully CBV compliant. But EPCIS is pretty much agnostic.
And if I remember correctly from one of your slides, you don't even have to use a GTIN, right? You can use
No,
something else.
you could use other identifiers, technically would validate.
Okay,
GS1, of course, encourages the use of its own GS1 identifiers, but it does recognize that not every product category, not every industry sector uses the GS1 system. So the standard is intended to be more agnostic.
that's great. That flexibility encourages implementation, I think.
Yeah.
Another question is,
It's important too, because we sometimes run into that misconception in practice, Andres, that that GS1 identification is required for EPCIS, but that's never been the case, not since 2007.
and I have heard that that idea. So thank you for clearing it up. Another question is has to do with understanding the state of the system at any point, right?
Right.
So an event-based approach like this suggests that if you want to know, say, what your inventory is, you have to sort of play back the movie, right, from some initial
Effectively,
state to get to where we are now. Is that how it
yes.
works, or is there
Yes.
some way
So,
to communicate a snapshot?
yeah. So every EPCIS event really represents a point in time and an observation or a change of state of something. So to work out the current state, you start with a known baseline state and then effectively play the movie forwards. Consider the cumulative effect of each of those events to determine what the current state is at the time where you stop playing the movie or stop analyzing the events. Um, within EPCIS event data, there are fields that have a forward-looking semantics. So, for example, we have a field for read point, which is where something was actually observed, but we also have a field called business location, which gives the prospective location where the thing is expected to be seen next. So, a simple example: if you have a retail store with a back room and a sales area, a sales floor, and you have a boundary door at the boundary between those two areas, and you maybe have an RFID portal reader between them. The read point would correspond to the boundary door, but the business location might be the sales floor or it might be the back storage room, depending on the direction of travel across the boundary. So it allows you to say what the prospective location is likely to be for those objects. And likewise, we have fields for business steps, so shipping, receiving, etc., packing, unpacking, but also prospective state can be expressed using the disposition or persistent disposition fields. So things like, the business step might be shipping, and then the disposition might be that this is in transit on its way to the next organization, for example. So we have, to some extent, forward-looking semantics in a couple of those fields there. But in general, you would have to consider the cumulative effect of the events.
Mm-hmm. Thank you. A third question. Does the EPCIS standard or some other associated, implementation guide define APIs for exchanging EPCIS events? And is this usually done, say, point to point between um, trade partners, or is it mediated by a hub of some sort?
It's usually point to point, and Craig mentioned, EPCIS standard defines standardized query and capture interfaces, and in EPCIS 2.0 onwards, we have a REST-like web interface so that you can query for events or even set up standing queries through that REST interface. And
Mhm,
also the capture interface also supports HTTP post.
mhm. Um, and
And there's no expectation that hubs are involved. It is very much peer-to-peer, point-to-point. It's
got
not
it.
like the global data synchronization network where there are hubs that then synchronize and sort of multicast or broadcast the
Mhm.
information. It's very much peer-to-peer, typically between direct trading partners.
Do you envision having services to allow these peers to find one another, or is that part of their business
That's that is a very long
initialization?
that's a very long story in GS1, and there's been a lot of discussion and efforts on things that we call discovery services,
Hmm.
which have not yet come to fruition. One of the challenges with EPCS event data and traceability data at serial level is that it's commercially very sensitive. So companies are very reluctant to publish that openly. So to work out whether the party who's asking for the data actually has the rights to access that is something where some of the evidence for it depends actually on the traceability data itself. So we have actually published a white paper. We can provide a link to that, which looks at how we could sanitize a collection of event data so that you could still check whether there's a chain of connectedness between the party asking for the data and the party who has the data, without revealing the data before, using that to determine the access, an access control decision. But it is quite challenging. It is also challenging because these paths through the supply chain are not predetermined. So for products that are made to stock rather than made to order, the final destination customer is not known by the manufacturer. So it emerges, things are passed through distribution networks, aggregated, disaggregated, split into, just to fulfill the orders that emerge. So the intended recipient is not known in advance. So it is quite challenging to work out who should have access. And so, as I say, it depends on this chain of connectedness and evidence for that. You might be able
You're
to do it with other mechanisms like a sort of two-factor authentication, where there might be a security code in addition to the SGTIN, and that might be sufficient in some situations. So if the manufacturer knows what the security code should be, for that particular SGTIN, then they might say, okay, you probably have it in your possession. And we do have something within the GS1 Web Vocabulary to handle that. So we did some work on digital signatures for authenticity. There's a technical implementation guide. We can link to that. And so we have mechanisms to support those kinds of additional product security features and to be able to link it to the data.
you guys are asking all the exciting questions internally. That looks great. If you can share that white paper, that would be, I think, very exciting.
Yes,
Then
link in chat.
we have moving over to the questions from the audience. We have a mega question from Glauco, which the answer for which probably takes like half an hour. But let me take a first stab at let me shave off some TC 347 stuff from that, if you're okay with it. So Glauco says from Brazil that he would like to see a single repository for domain tables like countries, units of measure, pesticides, etc., for agricultural systems. A single point of reference for developers everywhere. Do you think GS1 could be this place? Right? So what the things you mentioned, Glauco, fall within the category of what we call reference data, right? And some of those are already very well resolved. For example, the country codes that are normally used in the ISO system, for example, are the ISO 3166 codes. There's ISO 3166 Part 1 for countries and ISO 3166 Part 2 for second level
Subdivisions.
administrative divisions, right? And I think we all use that pretty much, right? If Glauco, if you look at the 7673 Part 1 document, you're going to probably see that and I mention it because it's foundational for our TC, that for countries, you're expected to use this 3166 Part 1. For first level administrative subdivisions, you're expected to use Part 2. And for third level and other stuff, there's like geo names or the FAO geopolitical ontology, right? So that's a solution. It already exists, right? For units of measure, that's a really tricky one, right? Because our industry has been super messy about that. There are organizations like GS1 and Ag Gateway and OAGI, for example, that use UN Recommendation 20 codes, right? Those codes are really good for doing things like representing all the strange kinds of containers in which things are shipped, right? So like cartuchos and 20-foot long containers and things like that, right? That have to do very much with supply chain. So UN Recommendation 20 and Recommendation 21 are a really powerful way of doing this. But those units of measure, that set of units of measure, doesn't work very well when you try to use it in field operations. I know because we tried, right? Some work that that came before TC 347 actively pursued using UN Recommendation 20 because it was very widespread in use in supply chain work, right? It doesn't work for a variety of reasons. We have a whole webinar on that topic, right? So if you look in our YouTube channel, we have a whole webinar on that. Not only that, but we have, as of today, as of about I don't know, an hour and a half ago, we have an active preliminary work item under Working Group 1, which is ISO 34706, which is actively pursuing a set of unit of measure codes and to provide guidance on how to use it. That will likely be the QUDT set, right? The beauty of the QUDT set is that the units of measure defined in it, in addition to checking a series of boxes that make them very friendly for the mass balance work that we do in the field, those units have direct links to the UN Recommendation 20 correspondences, right? So one of the multiple reasons why we're using them is because they allow interoperability with the world in which GS1 exists, right? So so again, it falls a little short of what you're asking for of a single repository, but it does have to do with some of that discoverability stuff that that the guys were just talking about. A third idea, which you brought up, has to do with pesticides, right? So there's several dimensions about pesticides because in order to properly use pesticide data, you need to know things like their modes of action, right? You need to know things like their active ingredients, which are the ones that actually have the modes of action. And you need to know how much active ingredient there is in that pesticide. So you need to know the formulation. The formulation references active ingredients, and the active ingredients are associated with modes of action, right? That highly detailed stuff is exactly the kind of thing that Working Group 1 is working on. Again, also, as of today, we have a ISO 34705 Part 7 project active that has to do with modes of action. That's going to be led by um, uh, Graham Mullier and Sarah Hovinga of Syngenta and Bayer. So all of these foundational pieces that are going to enable having unique identifiers for products that then can be used for automated label checking, for smart spraying applications and so forth are in progress, right? We need to find the nice handoffs, the places where GS1 can say, okay, I'm going to use this pesticide ID from some reference data provider, because they're companies that do this, right? They keep track of this complicated reference data for pesticides. That's not the sort of thing that you normally put into a just a standard, because there's a lot of frequently changing data. Some of the things like active ingredients you can put in a standard, and there's a standard for that called ISO 1750, right? So Glauco, if you're interested in those sorts of things, I would suggest that you join Working Group 1 or catch Stuart Ray, who is on this call, for a conversation to understand what's happening there, right? So uh, Mark, Craig, I'm sorry I jumped in. Do you want to add to that? Do you want to talk about what you guys are doing on that front?
I've provided a few things in chat. I certainly agree that QUDT is relevant for units of measure. We also have a unit converter tool linked from ref.gs1.org/tools.
Mm-hmm.
So you can look at that. We generally, GS1 generally aligns with UNEC Rec 20 for the unit codes, but
Mm-hmm.
and we typically don't replicate um, code lists from other organizations. We'd rather reference them just to make sure we're not providing stale information.
Mm-hmm.
I would suggest have a look at QUDT, maybe also have a look at Wikidata. So if you're struggling to get access to various code lists from any organization, it's possible that it might be available on Wikidata, which is extracted from Wikipedia. And just to reply to Christian's comment, GS1 is already investigating emerging standards relevant for discovery of those standards within data spaces and by artificial intelligence agents. So that work is ongoing right at the moment, and you can expect to see some machine-readable metadata for our standards, artifacts, and tools appearing on ref.gs1.org over the next few months.
Mm-hmm.
But it is
And
work in progress.
this pertains to Christian's question
Yes.
of
Yeah.
will GS1 become data space ready? So will you provide IDSA compliant connectors to connect GS1 system
That
with
is
data
certainly a
providers
priority
to
that we're
data
looking into. So we
spaces?
have a team looking into that right now.
Fantastic. Then,
There was one question about manual application of fertilizers and the role of GS1, which I'm not aware that there's a guideline which currently exists, but you would essentially capture that the same way EPCIS has been used for hospital procedures, administration of medication to human patients, capturing the fertilizer used, capturing the plot of land where it was done, and date, time stamp, etc. So that would be relatively easy to set up.
so that part, Mason, is something that you'd probably want to look at what Ad Hoc Group 8 is doing, um, uh, based on things like the adapt data model for field operations work, right? Which defines products and then captures where, when, how, why, and so forth they were applied and at what rate. And then by leveraging composition information, you'd be able to make calculations like how much you have per unit area. There is another ISO committee, I think it's 134, that we have an active ballot um, uh, for establishing a liaison with. They deal with fertilizers, soil amendments, beneficial substances, and we're on a quest to find a standardized vocabulary of fertilizer composition components, so like standardized codes for like nitrogen and sulfur and so forth, so that
So
we can
Craig's comment about Inchy key could be very relevant for that because that is a standardized mechanism for expressing identifiers for chemical substances.
true. And the Inchi key is a very good proxy for active ingredient units of I'm sorry, identifiers
Yeah,
in in crop protection,
right.
because the Inchi key is an expression, well, it's a hash of the expression of the molecular structure, right? And it's
Yes, that's
generally
right.
considered a unique enough identifier. We're trying to work out the finer points with ISO Technical Committee 81, which is the one that owns ISO 1750, because their data set has the Inchi key in it, right? And so um, uh, we've got some folks that are concerned that it's theoretically, since it's a hash, um, the Inchi key could have a duplicate, with some isomers or what have you. But that'll work itself out pretty soon. Let's
The
see.
so I think the Inchy is a hash of an identifier that does already handle stereoisomers or other kinds of isomers. So
Hmm.
they would have radically different entry keys because the hash is very sensitive to any change in the original input
Hmm.
string. So I don't think you have to worry about confusion between isomers of chemical compounds when you're
I
using
don't worry
multi-key.
about it.
No,
I didn't say I worried about it. I said
no,
we
I
have
don't think
people
anyone
that are
needs to worry
worried
about
about
it.
it. And the TC81 folks have said that so far since they started um, their register
They
um,
haven't found any
of them,
collisions. Yeah,
they haven't found any collisions, right?
no.
Okay, let's see. We're over time. I think we have covered all the questions. So, thank everyone very much for attending. Thank you, Craig and Mark, for this very exciting webinar. I think we've learned a lot. Um, it was great in getting people's creative juices flowing, I think, and asking great questions.
I would
Uh,
stop if you got 30 seconds. I did see an errand comment or a question here on the difference between serial number and batch lot. Whereas just to briefly go into that without
Please go ahead.
one says that the batch lot would pertain to a group of products or articles that were produced at a certain point in time. That could be an entire day of production. It could be one harvest from a field, etc. Serialization deals with individual instances. So even within a batch lot, you're talking about individual products, and that's important, particularly in the area where there's susceptibility to thefts, to counterfeits, where you want complete traceability, because otherwise it's difficult to tell the path that an individual instance has taken and to make sure that it's actually come from where it says it is. So that it's a much more specific level of identification. It's at the instance level one-to-one, whereas batch lot can pertain to very many articles.
Yeah.
Okay,
So
and
with serialization with SG10, G10 plus serial, it identifies one physical object that cannot logically be in multiple places at the same time, whereas a batch lot consists of potentially multiple objects that can be in different places all at the same time. That's the real distinction and the value of using serialization for traceability when it's important, as Craig was saying.
It goes back to your anecdote about going back to watch the whole film, Andres, and if you've had a dropout where you've missed 10 minutes of the film and then you see that the product has gone from the beginning of the film to the part that you tune back in at one point, you may have missed where, oh, in the meantime, it's gone someplace completely differently. And then if you did a plausibility check, you shouldn't expect to see it 10,000 miles from there an hour later.
Yeah.
Mhm. The good news is that I guess there's some recovery capability because with your transfer events, you're saying like where it's going to. So maybe it skipped a couple steps, but you still catch it where it goes next, right? It's not like you're saying now I move 2 meters forward and 5 meters to the left, where if you skipped a few, you really have no idea where you are.
Mhm.
The perspective stuff that you're talking about with business location, that means immediately
Uh,
subsequent to the event. It doesn't necessarily, it shouldn't be telling you, yes, this is now bound to a distribution center across town or across the country. You could use support for source and destination, which we didn't get into today. That's a topic for itself to indicate that, but that also only really indicates intent, and it's not an actual snapshot of where that thing is gone.
Mhm.
got it. We have one last question. Martin Kraft asked, when and where do agricultural products like crops, animals, milk, or their derivatives typically enter the GS1 tracing system?
Um, there's not really a GS1 tracing system. We have open standards. So it would typically be food integrators who use those ingredients to convert them into manufactured products that are then distributed and sold.
If the question is phrased along the lines of at what point do these agricultural products start to use GS1 identification, that's typically at the retail point or the downstream part of the sector that deals with consumers. Upstream, it's sometimes it's GS1 identifiers, sometimes it's something else. But anything that crosses the point of sale in a grocery store That's typically at latest at that point is when a GS1 identification would be applied there. But as Mark said, we don't have a GS1 tracing system. We have GS1 standards around identification, data capture, and data sharing. The latter is what we focused on today, where EPCIS is our flagship standard for data sharing, is at least in terms of
Event data
supply
and
chain.
traceability. Yeah.
All right. So thank you very much. And now we are out of time. So again, thanks to our speakers for a fantastic webinar, and thanks to all our attendees. Have a great rest of your day, and bye-bye.